Alright, let's start this week's class. So in this class we're gonna be talking about complex solutions. So have you heard of that? You know what okay. So do you remember how we factored previous class? Okay. So complex solutions are basically factors that are imaginary, right? So we refer to these as the letter I, right? So have you ever seen an equation like example x equals plus minus 3i, or no? You have? Okay. So this is what we call a complex solution. So um let me give you one of the problems. Complex solutions I don't think are factorable, so you have to use the quadratic formula. So as an example, we could do, let's do x squared plus x plus 1 equals 0, right? If we have something like this, if we identify our a, b, and so if we have this is our a value, this is our b, and this is our c. So our first step would be to set up the quadratic equation, which is just x equals negative b plus minus b squared minus 4ac over 2a, right? Do you remember doing this equation? Yeah. Okay. So then we could just plug our values in and we get x equals, and then negative b. b is 1, so negative b is just negative 1 plus minus b squared is 1, because 1 squared is 1, minus 4, and then our a value is 1, and our c value is 1. Yeah. And then over 2. So then x equals negative 1 plus minus, and then this is 1 minus 4, which is just negative 3 over 2, right? According to the discriminant rule, what would this tell you? What? Yeah. So there's no real x-intercepts. So a negative discriminant just means there's no real x-intercept. So there's no like real numbers, but complex numbers such as 3i, 4i are imaginary numbers. So they still exist within this plane, right? So we fully factor this out. This is what we graph. We would graph this on our plane. So we would graph x equals negative 1/2 plus minus square root of 3 over 2, right? And then we can approximate what square root of 3 is, right? Do you know how to approximate square root? No? Okay. To approx square root, to approximate square root, we do, let's see. So what are some squares that we know are next to square root of 3? And it's smaller than that, right? Square root of 3 is smaller. Okay. And then what's one that's smaller than square root of 3? Okay. So what value does square root of 2 give us? Square root of 2 gives you 2. Yeah, that would probably be an easy one. Let's object there. Okay, so square root of 1 gives us 1, and then square root of 4 is just 2, right? So we know square root of 3 is somewhere near 1 and 2, and since 3 is closer to 4 than it is to 1, we could roughly approximate square root of 3 to be, we could say like 1.87. That probably might not be true, but we can approximate it to that, like 1.8, 1.7. Right? So then we know that this over here is just 1/2 plus minus 1.87. Let's do a nicer number. So because we're dividing by 2, let's just do 6. So if we have 1.86, what's the half of 1.86? Jaworski. Yeah. Oh no, that's okay. Okay, so if we get 0.93, this is like if we tried like actually solving it, this is how we would graph on the complex plane. Right. Right. Sorry about that. So this is how we would graph on the complex plane using these points. Like we would get a point from this, but we could leave our answer in this form with the exception that let's see. Yeah, we could just leave our answer in this form, but we could take out an I, right? So we could do x equals let's see, what was it? -1 plus minus I 3 over 2, right? Because do you see how when we took a square root of a number, we took it of positive 3? So if we take a positive square root number, we can't really take a negative square root number because you can't equal that. That's why we use the letter I. Just signify that we're multiplying by a negative. Is that clear? I just said we take an I out of the square root when there's like a negative number, right? Because do you know how anything inside the square root is like half? Like square root of 3 is square root of 9 is just 3. So to get I outside, to get this I outside, we have to do square root of I squared, right? That is equal to I, and this I squared is just equal to -1, right? So that's why when there's a negative number, we could take out an I outside. Okay, so if you see a negative square root, there's no real solutions, but there's still imaginary solutions. that exists on the complex plane. Okay, do you feel comfortable? Do you think you should do a problem by yourself? Yeah? Okay. So let me give you a problem. Let's try this one. Your turn. Right, let's do x squared plus 2x minus 1 equals 0. Okay, and if you need help or if you get stuck, let me know and we could talk it through then. Okay? Okay, awesome. So let me know when you're done. What did you get? Okay. Yeah. Okay. Yeah, that would be right. And this is what we call is an irrational solution. Right, and would this be real or would it be complex? Okay, and why do you say that? Yeah, because there's no I. Right. Let me give you a harder one and see how you do, okay? So let's try 2x squared minus 4x plus 3. So if we do f of x equals that, try this problem out and tell me how it goes. Four plus minus what? I. Oh. Okay, let's go through this one. It looks yeah, let's go through this one. Okay, so I think you were on the right track, but I think you messed up somewhere. So let's look at our A values. So this is our A, this is our B, and this is our C. So using the equation x equals negative b plus minus b squared minus 4ac over 2a, we get x equals b is negative 4, negative 4 times negative 1 is 4. Let's plug in our numbers. Negative 4 plus minus b squared is negative 4, so it's negative 4 squared minus 4, and a is 2, and then c is 3, and this is all over 2, and then a is 2. Alright, are you good so far on what we have? Yeah, okay. So then if we just condense this down, negative 4 times negative is just 4 plus minus negative 4 squared is just 16 minus 2 times 3 is 6. 6 times negative 4 is, 2 times 3 is 6. 6 times 4 gives us 24. The minus sign stays. And then it's all over 2 times 2, which is 4. So then x becomes 4 over 4 plus minus 16 minus 24 is just negative 8 over 4. Then x equals 1 plus minus negative 8. We have to take out an I, right? And then this is still 8 over 4, but we can condense that because 8 is just 4 times 2. So then this becomes plus minus I, and then this, let me use a different color. This is just 4 times 2, so we could take out in 2, right? And if we could take out in 2, this becomes plus minus, this becomes plus minus 2i over 2 over 4. And then we could simplify 4 and 2 into just I divided by 2 over 2, right? Does that make sense? So I think you just got lost with your numbers along the way. But yeah, you were on the right track. So do you have any questions? Anything you want to clarify? No? Okay. Awesome. Let's see. Okay, I'll give you a couple more and then we could probably end class after I give you a couple more because this is all we really had to talk about today. Right? Since you don't have any questions, let's move on with the next problem. So let's say we have x squared plus 6x plus 13. Oops. Okay, could you try factoring this out for me? negative 6 plus minus 4i all over 2. Could you simplify this at all, or no? Okay. Negative 3 plus minus 2i. Yeah. Just keep in mind that we have to simplify or reduce the problem to the most reduced form it could be at, right? Okay. I mean, let's try one more problem, and after that we could probably end class. Because this is all we had to go through today to be ready for that next class, and you seem to be in pretty good hands. So how about you try this one? Think about this problem before you start solving right away. See how you could make this easier on yourself, and then we can go from there. Okay, sounds good? Okay, awesome. This is what you got? Uh-huh. That? Okay. I'll solve this one and then we can go from there, okay? Okay. So, first of all, without even solving this problem, I see that there's a 2, there's an 8, and there's a 20, which are all factors of 2, right? All factors of 2. All factors of 2. So we could then simplify this to just 2 bracket x squared plus 4x plus 10 equals 0. Okay, are you good with that so far? Okay, so then let's turn this into a focus point. Focus on this. So let's try using the formula negative b plus minus b x squared. B squared minus 4ac over 2a. When we do this, we get x equals, let's label our points. So this is our a, this is our b, this is our c. So when we do this, our b value is 4, so negative, and then 4, yeah, plus minus b squared, which is just 4 squared, minus 4, and then a is 1, c is 10, and then we put this all over 2, 1. So this step we just plugged in our numbers. So now let's condense this. What is negative times 4 is just negative 4 plus minus 16 minus negative 4 times 10 is just negative 40 all over 2. Then x equals negative 4 over 2 plus minus 16 minus 40. That would just give us 24, right? So if this, negative 24, sorry. This gives us negative 24 over 2, right? Now, if we break this down, this is just negative 1 times 4 times 6, right? Or you go with that. Okay. So this negative 1 is just I times I. This is 2 times 2. So we could take those out. So then we could turn this into x equals negative 4 divided by 2, just negative 2 plus minus, oops. And then we said that I could be taken out and then 2 could be taken out. So this just becomes 2i over 6. And then we can divide this by our 2. And then we could take those out. So it just becomes x equals negative 2 plus minus I square root 6. Yeah, we divided it by 2 to make it simpler, right? So, does that make sense? And just remember to, whenever you do it, because we have to multiply it by 2, right, according to our step here. So does that make sense? Make sense? Okay. That was the last problem I had in class today. So do you have any questions? Anything? No, okay. Yeah, with that, that brings us to the end of the class. Today we just learned about complex roots and complex solutions. This was just an intro class. We will do more about this next class, and we'll start learning about linear lines as well. Okay? Okay. yeah, you're free to go now. Have a great weekend. Enjoy your 3-day weekend.